This is the Bioscience Carrots A-Team Maker presentation. Our team consists of Johan Andrade, David Liu, Surya Kamalabhavanam, Anthony Guillen, and David Holguin. And this presentation will provide a proof of our concepts through both hardware and software. Our goal is to increase access to personal computer with assistive technology. The concept for our controller was worked on by all of us, and the modeling was done by David and Anthony, but the prototype build was completed by Surya, Johan, and Anthony. The controller will be built using an Arduino, 4 3.5mm female jacks, which are used for easier integration with the switch-adapted buttons, wires, and spare wood. And the controller has switch-adapted buttons with 3.5mm male jacks, and each connected button will be assigned a different value in the code, which will be further expanded upon in software. For a more detailed look of our controller, here we have the concept model. As you can see, there are 4 different buttons and 2 pillars that are on top of this base. The purpose of these pillars is that these platforms can be adjusted, and in doing so, increase the difficulty for the child. And what we hope is by increasing difficulty, the child can further develop their motor skills. So for example, while a child might start out on the bottom for the first couple of levels, when they finally start getting the hang of it, they can increase the difficulty by raising the platforms, and which we hope would further develop their motor skills by having them to reach higher and higher. As you can see through this hole and this hole, the controller is hollow inside, which is where the Arduino and breadboard rest. And this hole is designed for the wires of the buttons to go through here to connect to the breadboard, and this hole is designed for the Arduino to come out and deliver input to the computer through the USB. This is the prototype build that we have. Here we can see a better representation of what this might look like in real life, although we probably will not use Legos. As stated, we will be using scrap wood. As we can see here, it has the hole for the wiring, and this hole on the side is where the Arduino comes out of. And there will be 4 buttons instead of 3, we just didn't have one on hand here. So this is just to give a better understanding of what this might look like in person, but this is not to scale. For the software concept, it was once again done by all of us, but the sprite work was done by David H., and the programming was done by Surya and David L. And Level 1 wanted us to focus on the superhero, so we did that. But we did it through the form of a rhythm game and on Scratch. So the game acts as a side scroller, and what that means is that the whole world and the rest of the game moves to the left, but the player does not. And the child will be playing as a character that looks like Hulk, and the goal is to destroy as many buildings as possible. And each building has a color and number on it, and that corresponds to one of the buttons on the controller. So when the button is pressed that corresponds to the building and the character is close enough, it gets destroyed. And to work with buttons, character sprite runs the button code, and depending on which button is pressed, it'll send a message to the corresponding building sprite to check if they touch. And the more buildings destroyed in a row, the more points the person will earn, which we hope that will incentivize the child to do better. Here we have a proof of concept of our software. This is just a rough image of what this might look like in the future. So as you can see, as the player gets closer and presses the right button, the Hulk character-like model punches the building and destroys it. As shown in the video, there's these little things that indicate which button to be pressed, and so the child will know which button to press in time in order to break the building. We wanted to keep our budget under $50, and so below is a detailed listing of our materials once again and their respective prices. For our switch adapted buttons, we decided that the price depends on the type of filament being used in your 3D printer, and so we don't have an exact answer for that. For our Arduino Uno, that costs about $23 on Amazon. However, there's a cheaper substitute out there that does about the same things. It's called Elegoo, and it costs $10 less on Amazon. For our hardware, we use scrap plywood and a 2-inch by 3-inch plank. The plywood should be roughly about 18 inches by 10, but there should be additional plywood in order to construct the rest of the base. And once again, we aim that we use scrap for this. There's no exact price. And for our female jacks, These vary depending on your supplier, but they're around 75 cents per jack. So these should get you about $3 total. And in order for the adjustable platforms to stay stable, we're using nuts and bolts, which should run you for about a few cents each. And so we determined that the total price for our idea was about $28 to $43. These are all of our research links. This one shows how to set up your button. This is Scratch for Arduino, which was the program software we used. And these are the jacks for headphones that we're using for the buttons. And we use this video as an example of a student that we might be dealing with. And so it gives us kind of an understanding of how responsive our buttons need to be and how durable the controller should be. This is an example of a rhythm game that we got ideas from. This is an example of a side-scrolling background, so we knew what ours had to look like. And this is the file for the potential switch that you could 3D print your buttons from. And that is our presentation.